Hello everyone, today we will see how to recognize faces using only linear algebra. The first step is to convert images into matrices. We know that images are made up of pixels and each pixel has its own brightness. Based on the brightness, if it is completely black, we assign number 0 to it, and if it is completely white, it is assigned the number 255, and all the brightness in between, they are assigned the numbers from 0 to 255. So we know that images are made up of pixels. So we have like this one image you can see here 5112 by 341 pixels. So overall we will be having a matrix which will contain almost 1,75,000 numbers per face. In this example we will be using 4 faces and one testing face to match it with the 4 faces. The next step is to convert the vector convert to vector. The matrix will convert it into vectors. We have different rows in the matrix. Now, if we combine all the rows into one single column, we will get the vector. We'll stack all rows, and now each face will be a 1 point in 1,75,000 dimensional space. In the next step, we compute the mean of all the faces, average of all the face values. That will be our reference point. As you can see here, the blurry image, ghost image, because that is the mean of all the 4 faces. Next is step 4, which is the centering of data. We will subtract mean value from each of the face because we want to just focus on the differences, not the similarities between the faces. Then in the 5th step, we have to find out the covariance matrix. So if we see the order of the covariance matrix here, you can see it is 30 billion numbers the covariance matrix will be having. But using a simple genius trick, we reduce this calculation to just 16 number, retaining all the information. Next step is to find out the eigenvalues and eigenvector of this covariance matrix. So for this, we are getting 3 eigenvalues, which is lambda 1, which is covering almost 52% of all the variations, lambda 2, which is containing 32% of the variation, lambda 3 is containing 16% of the variation, and one more eigenvalue we have, which is 0, which is just having the noise, so we have just ignored it. So we have these 3 eigenvalues. Now we will create the eigenfaces. Again, you can see the ghostly patterns, which are the building blocks actually. Any face, you can write it as combination of these eigenfaces. In the next step, which is the dimensionality reduction, here we have 3 eigenfaces. We will throw away the rest 1,74,592. That means what we have actually done, initially we were in 1,75,000 dimension and we have just reduced the dimension to 3 dimensions. That is the dimensionality reduction. And in the next step, it is just the projection to the eigenface space, which is 3D space. Now each face becomes a 3D coordinates now. Like you can see, the test face value is this simple 3D vector, which is 18.9, 4.1 and minus 0.9. Step 10 is to just measure the distances of this test face from all other 4 faces. And we can see from the values that the closest face is face 1. So this is how the face recognition uses linear algebra, from images to matrices, from matrices to vectors, and from 1,75,000 dimension to just 3 dimension. No AI magic, just beautiful mathematics. That's the eigenfaces. If you want to know all the details, the mathematical calculation and all, you can find out the link in the description for the complete detailed video on these eigenface algorithm. Thank you for watching.